Right, part two. Part two is about the determinant of some special matrix. Okay, these all four matrices in part two, they are special. Okay, the general way to get the determinant of a general matrix is discussed in problem three. Okay, in problem two, we will first look at some special cases. Okay, first special case, it's part A and part B. What if the matrix is an upper triangular matrix or a lower triangular matrix? What does that mean? Okay, for example, this matrix is an upper triangular matrix. Okay, let's first write down the matrix. Okay, this matrix is an upper triangular matrix. Okay, so what does that look like? Upper triangular, you draw this upper triangle. Okay, whatever in this upper triangle, I don't care. But whatever outside this upper triangle must be zero. Okay, that's called an upper triangular matrix. The upper triangular matrix, you draw this upper triangle, including the diagonal entries. Okay, all 3, 5, -2, they are included in this triangle. Whatever inside this triangle, I don't care. These numbers can be zero, can be non-zero, whatever. But whatever outside this upper triangle, they must be zero. Okay, so this is an upper triangular matrix. So something you're going to confuse it with is this is what is called a lower triangular matrix. So as you can expect, it is the opposite. In part B, it is a 4x4 matrix. Okay. All right, same thing, lower triangular matrix. So you draw a lower triangle, and whatever in this triangle, I don't care. Sorry, let me draw it. Draw a better one. Whatever in this triangle, I don't care. But whatever outside this triangle, they must be zero. Okay, this is called a lower triangular matrix. Okay, again, we only talk about upper or lower triangular matrix when we talk about a square matrix. Okay, first this matrix must be a square matrix. It must be 3x3, 4x4, or n by n. It must be a square matrix. Then we talk about whether it's an upper triangular or lower triangular matrix. Okay, for these special types of matrix, let's call it the matrix A. Okay, the determinant of that matrix is very straightforward. It's just the product. Okay, this is the symbol for the product. It's just the product of all its diagonal entries. So it's just diagonal entry times diagonal entry times diagonal entry. Right. Okay, this only works for upper triangular matrix or lower triangular matrix. Okay, this is not a general formula for determinant. Okay, I have to tell you. So it's just a product. In this special case, it's just a product of all the 3 diagonal entries, A11, A22, and A33. So it's 3 times 5 times -2. The result is -30. Okay, similarly, let's call this matrix B. The determinant of this 4x4 lower triangular matrix is again the product of all its diagonal entries. So it is B11, B22, B33, and B44. The product. Okay, square root 2, square root 2, -1, 6. Result is -12. Okay, again, I must emphasize this only works for upper or lower triangular matrix. Okay, third, part C. This matrix is a special matrix. Okay, why it's special? Because it has a row of 0. Its second row, all entries are 0. Okay, its second row, all entries are 0. So a general rule, whenever a matrix has a 0 row, or as you can expect, if the matrix has a 0 column, okay, no matter it has a 0 row or a 0 column, then its determinant is just 0. Okay, you don't even have to do the calculations. You don't even have to use the formula. As long as it has an all 0 row or an all 0 column, then the determinant must be 0. Okay, then the fourth, okay, the third special case is when a matrix has two identical rows or two identical columns. Okay, in this case, this matrix, it has two identical rows. Okay, but if it has two identical columns, for example, if two columns look exactly the same, then again, you don't need to apply the formula of the determinant. You can just write down the result. The result is 0. Okay, whenever a matrix has two identical rows or identical columns, the result is 0. Its determinant is 0. Okay, a quick summary. So when it's an upper or lower triangular matrix, the determinant is just a product of all the diagonal entries. Product of all the diagonal entries. When a matrix has an all zero row or all zero column, its determinant is 0. Okay, when a matrix has two identical rows or identical columns, then its determinant is also 0.